Afternoon. Welcome, everyone, and thank you for joining our Faculty of Agriculture and Food Sciences conversation series. My name is Nazem Chichek, and I'm the Associate Dean Research in the faculty. And today's seminar is entitled Weathering Risk, a new tool for Fusarium head blight disease risk management. Before I start, I'd like to acknowledge that the University of Manitoba is located on the original lands of Anishinaabe, Cree, Oji-Cree, Dakota, and Dene peoples, and on the homeland of the Métis Nation. We respect the treaties made on these territories, we acknowledge the harms and mistakes of the past, and we dedicate ourselves to moving forward in partnership with Indigenous communities in a spirit of reconciliation and collaboration. So if you're new to the Faculty Conversation Series, it is basically our virtual seminar that highlights some of the innovative research that's happening in our faculty, hopefully in an engaging discussion format. If you missed our previous seminars, there's an opportunity to view them right here on our faculty's YouTube channel. As another option, you can also find links to the seminars at our knowledge translation portal, which we call the Manitoba Agriculture and Food Knowledge Exchange, or MAKE. And makemanitoba.ca highlights our faculty's research as it relates to consumers, producers, with links to resources such as podcasts, fact sheets, infographics, and even some recipes. So today we have three speakers who will share with us a short summary of their research and then engage together in a conversation. You as a viewer can participate in this conversation by sending in your questions and comments via the chat platform Slido. So right now, I'd like to call on Crystal Jorgensen, the faculty's communications specialist, to provide some guidance on how the audience can participate in today's presentation. Crystal?
Thanks, Nazem. Welcome everyone who's joined us today. We hope that you'll help us out with some questions for our speakers. And to do that, you can open another browser window and visit slido.com. And when you're there, you'll enter the event code #headblight, all one word. And feel free to start asking questions at any time. When we get to the Q&A portion, we'll work our way through them in chronological order. The question field is a little bit limited in character count, so maybe keep your questions succinct as possible. And just to kick it off, we'd love to hear where people are tuning in from today. And with that, I'll turn it back to you, Nazem, and we can revisit these instructions a little later on.
Okay, great. Thanks, Crystal. So we will review those instructions right before the Q&A again, and we'll go from there. Okay, so today's conversation will explore a topic that challenges many of our cereal producers across the prairies. It's the fungal disease known as Fusarium head blight, or FHB. And FHB can result in reductions in yield, quality and grade, and end-use quality of cereal grains. FHB thrives under moist, warm conditions and is particularly prevalent following high moisture weather events that occur when a cereal crop is nearing the flowering stage. Strategies have been developed to help producers mitigate the impacts of FHB by breeding varieties with higher FHB resistance rating and applying fungicide at the best time. However, the level of FHB severity is highly variable in different areas and even in different years. And as we know, we are experiencing greater variability in weather with more frequent occurrence of extremes such as drought and flooding. So the question is, how can we help farmers better prepare for this weather variability, in particular for a disease such as FHB, which may be very severe one year and really non-existent the next? So are there tools that they could use to better inform themselves about whether they need fungicide application to suppress FHB? So today we will hear from two of our academics who work in the area of agricultural meteorology and a Manitoba agriculture specialist who is a systems modeler. They're here to tell us about the tool they have developed together based on pan-provincial data, which can calculate risk levels using weather-based algorithms in real time. So now I'd like to introduce you to today's guests, and let me start by welcoming Paul Bullock, who's a senior scholar in the Department of Soil Science. Paul was formerly professor and head of the Department of Soil Science here at the University of Manitoba. He has a BSc in Agriculture and MSc in Soil Science from the University of Saskatchewan and a PhD from the Center for Resource and Environmental Studies at Australian National University. His research in agrometeorology has included crop modeling, crop risk assessment, and soil moisture assessment methods. So over to you, Paul.
Okay. Thanks very much for that introduction, Nazem, and hello to everybody who is listening into our conversation today. So I wanted to maybe put this in the form of a little bit of a story. It's almost exactly 5 years ago, April 1st, 2018, that this project officially got underway with a huge group of collaborators. We wanted to embark on a project with the specific objective that Nazem just mentioned. We wanted to create a system that could use real-time weather data to delineate risk for FHB across the prairies. And these collaborators spanned Agriculture and Agri-Food Canada, provincial agriculture departments in Manitoba, Saskatchewan, and Alberta, as well as colleagues here at the University of Manitoba, including myself. And we knew from the start that this objective could be achieved because there's a similar system actually in operation in the USA. There was a desire and a strong support for us to create a pan-provincial FHB risk mapping tool that was developed using our own cereal crop varieties and representative of the Fusarium species and chemotypes that we have on the prairies. And during this project, we've managed to expand the FHB risk assessment. If you go to the USA and look at their tool, they'll give you risk of FHB occurrence in winter wheat and spring wheat. Our tool that we're going to describe today will do that for winter wheat, spring wheat, barley, and durum. And further, we actually developed risk assessments for Fusarium damaged kernels for spring wheat and for durum, as well as dawn for durum. So our tool actually has ended up providing a much more comprehensive FHB risk assessment than what you'll find in the US, and we're quite proud of that achievement. So this project has three main components, and the slide you're looking at is giving you an overview of that first component. It was a plot study. It was conducted in the growing seasons of 2019, 20, and 21. Those locations, there were 5 in each province for a total of 15 in each of those 3 years. That gave us up to 45 site years of data to work on to develop the models. And at those sites, we had to take detailed weather observations because we need weather data if we're going to do the model development. We grew 3 varieties of spring wheat, winter wheat, and barley at each site. And those varieties were selected to have a range of resistance from resistant to intermediate to susceptible to FHB. And we grew those same varieties from the same seed lot in all of the different locations so that we knew that anything that we saw in those plots that was different in terms of FHB response was because of that resistance difference, not because of differences in variety between sites. 4 replicates in every plot, and we measured FHB visible in every plot during the filling stage. Then we harvested and we brought that grain back to Winnipeg and we had it graded. So we had Fusarium damaged kernel counts and we did dawn analysis as well. So we had weather from those plots and then we had the actual Fusarium head blight response that occurred in those plots. And that's what you need to make these models. The second component of this project was a producer field study. And that's what I'm showing on this particular map, okay? We had producer collaborators who gave us access to their fields, more than 300 fields across the prairies that we could use to collect observations and grain samples. And at those locations, we took the same observations that we did in the plots. We measured FHB visible at the filling stage, and we harvested the grain, and we tested it for FDK and dawn. Then what we did at each of those fields is we found the nearest weather station, and we used that weather station to provide weather data to calculate the Fusarium risk with our models. And then we could compare that to what we had actually observed in those fields. So this gave us that really critical comparison. It was very, very important. The purpose behind this whole project was to develop risk models that can provide farmers with information about risk for Fusarium head blight in their fields. So we had to be sure that the models that we developed were accurate in producer fields. So we went through that and had a successful validation of these of a set of models. And we went then to the third stage of the project, which is what we want to talk about today. And that was to develop a Fusarium head blight risk mapping tool that could be used by anyone if they wanted to see whether the risk for FHB was high or low in their location. It's meant to help producers decide, is it worthwhile applying a fungicide at the flowering stage of a cereal crop to help suppress FHB? Remember, at the flowering stage, there's no sign of FHB. It won't become apparent for 2 to 3 weeks later. So making that decision can be a bit of a risk. So we had to have a mechanism where we could communicate that information to farmers, and that's what we're going to do today. The project officially ends March 31st. So I can say it's very satisfying to be able to tell you that we're planning to make the FHB risk mapping tool accessible. Right now, the plan is for April the 12th. We'll be sending out a press release to publicize that and make it known to people. And, you know, this project was a really massive effort, just a huge number of people that were needed to bring it to a successful conclusion. And I just want to take a second right now to thank everybody who was involved to get us to this result.
Okay, great. Thank you, Paul. This is really impressive work. I just wanted to make sure that people have a chance to you know, take that information and think about it and see if they have certain questions about it, and they can certainly put that into our chat. But next, I'd like to introduce Taurai Matengu, who's a PhD student in the Department of Soil Science. And Taurai has a BSc in Plant Science from the University of Zimbabwe and an MSc in Soil Science from the University of Manitoba. And his MSc research focused on developing FHB risk models to mitigate FHB epidemics in Western Canadian cereal production. And the models that we'll be discussing today, those were the ones that he developed that are now used in the new online tool for FHB risk mapping. So go ahead, Taurai. You can take it.
Thank you very much for the warm introduction. Yeah, so for model development, we used a logistic regression modeling approach. So firstly, the response variables, that is the FHB index, FDK, and DON, were classified into two classes of epidemic, that is coded as 1, and non-epidemic coded as 0, using different thresholds. So for example, the FHB index utilized 10 and 5% thresholds. And the 10% threshold is the one that is utilized in the US FHB modeling. And observations of FDK were also classified into epidemic and non-epidemic cases using 0.8% threshold for winter wheat, 0.3% for spring wheat, 0.2% for barley, and 2% for durum. And FDK threshold reflects the maximum level permitted in the number 1 grade for each crop type under the Canadian regulation. And this serves as a justification for the application of fungicides to avoid the revenue loss due to downgrading. And the DON threshold correspond to the value that results in wheat toxicity and refusal by some buyers during marketing, as established by the Canadian Food Inspection Agency. So to develop logistic regression models, so the weather variables were treated as predictor variables. So we calculated 80 weather predictor variables from 5 durations around flowering. And that is 4, 7, 10, and 14 days before mid-anthesis, plus a period between 3 days before and 3 days after flowering. So these variables were obtained firstly from the calculation of mean daily values, for example, mean daily rainfall, which is highlighted in red. And secondly, from the duration in hours of a pre-specified weather conditions. For example, the duration in hours where air temperatures between 15 and 30 degrees Celsius. That is the values that are highlighted in blue. And thirdly, from the combination variables, for example, a combination of temperature and relative humidity. For example, the duration in hours where the temperature is between 15 and 30 degrees Celsius, and where relative humidity is greater or equal to 90%, that is in green. So the model selection was based on a number of factors, including accuracy and simplicity. And here's an example of selected spring wheat FDK model which utilizes only the mean, the relative humidity at 10 days before mid-and-day season. Sorry about that. So on the right is the graphical representation of the model, and it splits moderately susceptible variety, intermediate, and moderately resistant variety. And however, there was no significant difference between these varieties. So that means that regardless of the variety, the probability of FDK epidemic risk will be the same for all the varieties. And the probability value that best separates epidemic cases and non-epidemic cases is known as the optimum predicted probability. And we use this value and the standard deviation method to further classify the risk into low risk, moderate risk, high, and very high risk. And we validated the models that we developed using an independent dataset that we collected from several research fields across Western Canada. And from this table, we see that sensitivity, which is the ability to distinguish epidemic cases, was low for most of the FHP index models. And this was due to lack of epidemic cases to predict. So we're dealing with dry years. However, the overall accuracy of the selected models that are the models highlighted that are in bold across all crop type were greater than 70% for FHP index models, and greater than 80% for FDK models, and greater than also 80% for DON models. So I'll leave to the next presenter.
Okay, thank you. All right, that was an excellent description of the model itself. And next, I'd like to welcome Tim Ojo, who is with the Climate Resilience Unit, Land Use and Ecosystem Resilience Branch with Manitoba Agriculture. And Dr. Tim Ojo is the Agricultural Systems Modeler with Manitoba Agriculture, where he develops agronomic tools using weather data. He obtained both his PhD and his MSc from the University of Manitoba, and his bachelor's from the Federal University of Agriculture in Nigeria. He is the current president of the Canadian Society of Agricultural and Forest Meteorology and a past president of the Manitoba Soil Science Society. So take it away, Timi.
Yeah, thank you very much for the introduction. And I would say part of our mandate at Manitoba Agriculture is to find ways to connect agricultural research with practical application that producers can benefit from. And it's quite similar to the university's knowledge transfer plan, so that right from the proposal development, my responsibility on the project was to find ways to transform the research component of the study into tools that producers can make use of to make informed decision. And that's what has led to the FHP risk mapping tool that I will describe in a moment. The tool takes the models that were developed and validated into an online platform that producers across the prairies can access on any digital platform with a browser, so cell phone, tablets, computers. And the screen you're seeing is from a cell phone screenshot. And I would briefly go over the platform. I've included the link to the mapping tool on this page, but if you were to visit that link, you would notice that it would show that the tool would be available in 2 weeks' time. So that's on April 12th, as Paul mentioned. So a click on the Go to FHP mapping tool would actually take you to this home page, and the home page has information on the purpose of the risk tool, a description of the risk parameters. So what does FHP mean? What's FDK? That's the Fusarium damage kernel, and DON as well. And it would also show you just a quick preview of how the map works. And very importantly, the acknowledgement of the funding partners, the weather data providers, and the support we've received from the provinces. So like I mentioned, this screenshot is from a cell phone. And when you click on the use map tools, use map buttons, yeah, right there. First-time users will actually see a screen that shows a brief 7-step tour of how to use the tool. But if it's not your first time on that browser, then it would simply remember that you've visited the tool before and would simply show you what you have on the right hand side of the screen. So it's simply, you would have to go through the steps of selecting a date. And as shown on the screenshot right now, the date I've selected was June 25, 2022. Now, because FHB is limited to the flowering period of cereal, we have limited the date selection to May 15 up until August 31st. So any date outside this range, outside May 15th to August 31st, would be grayed out, and you won't be able to select, let's say, a day like today, March 29. So once you select the date, you would select the crop type. As Taurai mentioned, we looked at winter wheat, spring wheat, barley, and durum. Those were the 4 crops that we reviewed in this project. And then every year, we also make sure that we look at the seed guide to pre-populate the list of varieties. So you would also select the variety that you have seeded or that you plan to seed, and then the type of risk you want to see. So there's the FHB, the Fusarium Blight, there's the FDK, and the DON. So once you've selected that, you would click on the show results. And here I've actually switched to the desktop view so that it's much bigger. And this is the view for July 22nd, 2022. And you would notice that here it's showing that Manitoba has a very high risk for FHB index on that day. Now, this does not mean that every field under the very high risk level would show FHB. So it does not mean every field in Manitoba would have FHB damage. However, the tool is a prompt, and it prompts producers to scout their field if it's within the flowering period. And if you're interested to see the weather stations used to drive the model, there is a little hamburger icon right at the bottom right corner of the screen, and you can toggle that on or off to see the weather stations that are used in driving the model. And producers who may want to share the information with others on their farm, or want to simply keep the record for record purposes, they can select export, which is right at the top right corner of the page. And selecting export would show up with a page with an image of the map. And as well, it would have a pre-populated map details based on the filters that have been selected. The document can be downloaded as an image file, like a JPEG, or it can be saved to file as a PDF. And I'll quickly mention 2 other features that are quite important to note. There is the weekly crop report tab right at the top of the map. And this tab provides a direct link to weekly crop reports for each of the 3 provinces. Those reports are updated weekly by provincial specialists, and they provide very relevant information on the current cropping situation in each of the 3 provinces. And we also have the FAQ section, and the FAQ section simply provides answers to several questions about how to use the tool, what the tool is for, and in developing this tool, we had a test group comprising of farmers and agronomists, and the feedback we got from them was very helpful in designing this mapping tool. But we are still interested in receiving further feedback on this tool. And so yeah, the launch date for now, we are planning in 2 weeks' time, April 12th. And this would give producers at least more than a month to be familiar with the risk mapping tool before they indeed are required to use it in late May or early June, especially for winter wheat. For spring wheat and barley, most farmers will likely not need it because the crops won't get to flowering until late June or early July. So that's what I have, and I'll be looking forward to further conversation and questions.
Great, thank you so much, Timi. This is really a great example how science from the plot studies and field studies can turn into important information that farmers can use on a daily basis. and that knowledge mobilization aspect that we always are looking for in projects. So thank you for this important work. This would be now a good time for us to have a bit of a conversation around, in general terms, around some of the aspects of your work. And then in the meantime, I'll invite people to write down their questions and pose it to the group as we go through this conversation. So maybe I'll start you off with a general question, which deals with, I understand there is some FHP risk maps that are already available to the public, and you can correct me if I'm wrong. What does this particular new tool add to that, and why was it necessary to create it? Paul mentioned it a little bit, but I think it'd be useful to rehash that at this point. Maybe I'll start with Paul first.
Sure, yeah. Yeah, and that's very true. If you go to the agriculture web pages in all 3 provinces, you can find Fusarium head blight risk maps, and that is correct. Now, the reason that we had such strong support from the provinces to do this project was because, I mean, those information products are there, they have them, but they're working with imported models. They imported the models from the USA, and for the most part, they really have gone untested in Western Canada. Like, how well do they work? Really couldn't say for sure, because and it was quite a while ago. We're not sure that even if they did work 20 years ago when they were first brought here, that they would still be relevant now. So that was part of it. The other thing is that it wasn't consistent. The model would vary from Manitoba and Alberta had the same, and then Saskatchewan had a different model. So you had farmers who would tell us, well, I'm right on the border, and if I click on the map in Manitoba, it's showing high risk, and then I click on the one in Saskatchewan, it's saying it's low, and that was possible because there were different models using different time frames in that. So this was meant to address that, to have it consistent across right across the entire prairie region, so that you wouldn't run into those sorts of things as an issue again. So that was the main reason behind wanting to take this next step.
Yeah.
Go ahead, Timi.
Yeah, if I can just jump in as well. We also know from colleagues in AAFC doing some research on chemotypes, and even at the U of M as well, like Paul mentioned, that we've actually had a change in the dominant chemotype. Yeah. We used to have, I think it was the 15A Dawn that was the dominant type in the past, and now that has evolved. Now we have the 3A Dawn being the more dominant chemotype that we have. So with the change in chemotype, it also would likely there's a need to update the model we use to see if the same thresholds that we were using before are still relevant with this evolving chemotype that we have.
Okay, well, that's interesting as well. So you're really trying to make a model that's more uniform across the prairies, that you can rely on, that's validated, and is updated to the realities of today. So that makes a lot of sense. So you mentioned, Timi, that you use certain weather information or weather data. Even there was a button there, you could see where the weather stations are located. Can you speak to us a little bit more about exactly where those weather stations might be, how many may be in general terms, and how do you use that information that's coming from each station to help you calculate the risks levels that you're showing in the model itself?
Yeah, no, that's a really good question. And I would maybe start by really taking the opportunity to also acknowledge the support that we have from all our data partners. In Manitoba, we have such an excellent support from the province with the increase in the number of weather stations we have. So Manitoba currently has 120 weather stations, primarily dedicated to agriculture. And it's been very valuable to be able to bring that data set. As well, Saskatchewan, we've been able to partner with Saskatchewan Public Safety Service, and they've also provided very wonderful station. I think they have about 34 stations. And in Alberta, they've got the Alberta Climate Information Services, again, wonderful partners, providing access to over 300 stations. So across the prairies, we are actually feeding in more than 500 weather stations into this platform. So every morning at 3 a.m., we have an automated call such that we are able to download the data automatically without having to do any manual process. It's already been pre-programmed. So we have a call out to the various partners. And I should also mention Environment and Climate Change Canada.
Yeah.
Very, very important data set that we've got. And so we have all these data sets coming in. And like Taurai mentioned, we are using information such as mean relative humidity, temperature. So these are important information that we receive from the individual stations. And with the data coming in at the point level individual stations, we actually use those information to create the probability of occurrence. And based on the probability, we have the map being displayed. But what we do, because we also don't want to just have one station having the dominant effect, so it's a gridded platform, as you would notice from the map I showed when I was presenting. So the resolution we have is 10 kilometer by 10 kilometer gridded platform. However, we have 12 stations contributing to any grid cell that you would see displayed. So we use what we call in geospatial analysis, it's called the inverse distance weighing, which simply means that the closest station would have the greatest impact, or we have more weight on the risk that is being displayed. However, we also have other stations around it that contribute to what is being seen. So having such a very good resolution of weather station is actually very helpful in terms of contributing information to run this model. And that's also something that I think we've really also maybe an advancement to what we used to have before.
Yes, right.
In the past, the models were run with stations as low as maybe 40 stations in Manitoba, for instance. And over the last few years in Manitoba, especially, we've been increasing the density of the network. And I would say across the prairies, we are also seeing that occurring as well.
Yeah.
Yeah, no, that's great. And I was just about to ask, how has that changed over time? Obviously, you mentioned more recently there's additional weather stations being established right across the provinces. So is this fairly recent, or has this been going on for the last 10 years or so? We just haven't taken advantage of it in terms of our modeling. Could you speak to that at all?
Yes, so the increase has been fairly recent. I would say in the last 7 years, we've actually Manitoba went from the Manitoba Agriculture Weather Program, because we also have another weather program through the fire services as well that cater mostly to the northern region, the forest areas. But within the agricultural program, we had about 46 weather stations up until 2015. And in the last 7 years, we've actually more than doubled the number from 46 now at 120 stations in Manitoba. In Saskatchewan, there is also the ability to use new data sets. I know Saskatchewan would have some other weather data sets coming in from private industry, as well as Environment Canada. But we are able to also use the Public Safety Board, who initially the stations weren't necessarily designed for agriculture, so to speak. It's mostly for public safety, but the data they provide are equally very valuable for use. And if I can also quickly speak to the question we often get about the data to include some private organizations or farms that have privately owned weather stations have actually asked us if they can contribute data to the project. And the main thing is we would take data. However, we want to ensure that the data we are taking in follow the Canadian standard for meteorological station siting and instrument calibration. So we would welcome any discussion from anyone that owns, let's say, a network of stations, say 10 stations or more, as long as the siting and instrument calibration follows a standard, such that because we like to know the frequency of sensor calibration, the type of data quality and assurance, before we can start using such a data platform.
Yeah, no, that's important. Obviously, you want to rely on that data, and the more the better, but it has to be high quality, right? So that
Correct.
makes sense.
Yeah.
Maybe a different aspect to chat about also, if I understand correctly, both the FDK and the DON risk models were not validated with barley or winter wheat. Is that correct? And if that's so, Why was that not done yet, or is that being worked on? Taurai, would you like to comment on that from your end first, and maybe others can chime in?
Yeah, for sure. Yeah, so to develop a valid logistic regression model, you should have at least 25% of either epidemic or non-epidemic cases. And because of the dry years that we experienced between 2019 and 2022, so we couldn't develop all the models. That is why you see that we currently don't have, for example, winter wheat and barley FDK and DON models. And it's because that they had less than 25% of epidemic cases. The disease pressure was quite low for those crop types. So currently we don't have the models for those crop types, but I hope that as we continue to collect more data, we are going to be able to develop models for these crop types and damage indicators.
Yeah.
Okay.
Yeah, so it would be nice to fill those gaps in the future for sure. But yeah, that did pose a bit of a challenge for us in that, we had 3 dry years right at the time when we were trying to collect the data needed for the modeling. Hey, what's new in research? That's what always happens, right, when these things get put together. But yeah, we'd like to see whether we can in the future collect, and it needs to be good quality data that's reliable, that we can use to build our database. Like in the US, the one advantage they have is they've got long-term stable funding, and they've had their wheat and barley Fusarium initiative going for more than 20 years, and they have more than 20 years of data. I mean, we got a great start. 45 site years was a good start, but we really need to add to that over time, and that would help facilitate that hopefully you would then get a large enough sample with enough epidemic and non-epidemic cases to be able to actually have valid logistic regression models. So that's something for the future for sure.
Yeah, a few good years for the farmers. Unfortunate luck for you guys.
Well, yeah, exactly. It depends how you look at it, right? But
we wish many more good years for the farmers, and we can study whatever comes our way anyway. But I understand. I think these type of models are fed by good data, and it takes time to validate all aspects of it. But
right, yeah,
great start already.
Yeah, and that is really key. Like that's why we really insisted on testing them in producer fields and make sure it was tested rigorously, and that because to put information out there without really being confident that it's giving you an accurate nobody felt very good about that. So it is important you get good quality data, you test rigorously, and that you can feel some level of confidence in what it's telling you. So certainly there's a dry bias in the data set right now. This is partly, I think, Taurai mentioned why we can't yet distinguish between the Fusarium responses of resistant versus intermediate versus susceptible varieties. And the reason, I think, is because we didn't have a lot of epidemic cases, and you normally see bigger separation in their responses when disease pressure is high. And so I think that's been lacking, and so we're not able to distinguish that yet. But again, in the future, you add more data to this, hopefully it'll start to delineate those different responses and become even more reflective of each farmer's individual crop type and variety in terms of how it might respond.
Yeah, go ahead, Timi.
Yeah, and if I can chime in as well, in the tool we developed, we did not include the 3 risk levels or in terms of the susceptibility levels. So we did not include specifically for visitors to select, is my variety moderately resistant or is it susceptible? That's all done in the back end. We recognize that most producers, and it's also part of the feedback we got when we had the producers test this, most producers would easily know the variety they are seeding, but may not actually know the level of resistance that for to FHB. So instead of having producers to select the level of resistance that their variety is, it's easier for them to select the variety, and then in the back end of the tool, it's determining which level of resistance that would be, and then we generate the model appropriately.
Yeah, I mean, you've done the hard work already, right? You established partners, you hooked into weather stations, you've done your plot work. And I think it's just a matter of time to refine some of the modeling parameters as data flows in. So I think it's just as new varieties get validated, as new conditions are there, and maybe some unfortunate years of more disease, that is all going to help you with validating those models. So
That's right. Yeah.
that's great. I think we want to take a bit of time to let the audience ask us some questions. So I think they're coming in already, from what I understand. But Crystal, if you don't mind repeating at this point some instructions to our guests on how to post questions.
For sure. So if you can open a browser window, another browser window, and go to slido.com and enter the code hashtag #headblight, all one word, and then just type in your question there, and we'll answer them in chronological order. And as I mentioned before, the character field is a bit limited, so try to keep them succinct. And we did ask right off the hop, where are you watching us from? We had a few people respond. We've got people out in Carmen and Winnipeg, and I'm sure all over Manitoba and maybe beyond watching us. And yeah, we've got about 6 or 7 questions in the hopper now, so we'll get to those.
Great, thank you so much, Crystal. So I'll just start posing them as they come in, and whoever has an answer for us can jump in. So the first question comes from Andy, and Andy asks, did I hear correctly that the resistance did not have an effect on the probability of FHB epidemic, or is that considered in the variety?
Right. Yeah. Maybe I'll just reiterate. I kind of spoke to that a minute ago, Nazem, but yeah, as Timi just said, we don't ask anybody, what's the resistance level of your crop. So I'm growing spring wheat, and it's AAC Brandon. So you put that in, and then it knows in the back end, it knows that Brandon has a moderately resistant to FHB, and so that's how the resistance is considered. We couldn't see differences in the models. I think we could see them, but they weren't statistically significant. We don't have a large enough data set, and we didn't have enough extreme disease pressure to really see those differences express themselves in the models. So at this point, no, we're not distinguishing them because we can't, but we expect to be able to do that in the future as we add more data from higher disease pressure years.
Right, and I think the next question actually relates to that, the next couple, and they deal with, the fact that you went through some dry years. So Pam asks, can you please comment about the drier conditions over the past several years and the impact to model validation? I think we covered that to some extent, but if you have anything else to add, this would be the time. Do you the follow-up question by another guest was around drought conditions versus rainfall conditions. Do we expect rainfall to result in higher FHB? So maybe you can address that.
Maybe Taurai, because I know Taurai showed a slide that had the different the sensitivity and the specificity of the models. Specificity was pretty good because those are the non-epidemic cases, and we had lots of them. But then the sensitivity was difficult because we didn't have a lot of high disease, so it was more difficult to validate. So, I think that's partly what was in your table, Taurai, was showing the effects of those dry years and how that affect our models.
That's right. Yeah. So from the table, yeah, we can see that since we're dealing with dry years, the sensitivity, which is the ability to classify those epidemic cases, were low because there was no epidemic cases to predict. So I believe that if you take these same models where there are wet years and high disease pressure, we don't know how they're going to perform because they're not tested yet. So in terms of sensitivity, we are not confident with the sensitivity. That's why we need more data collection to test further these models, because we have a dry bias. We only know that they are very good at predicting. The specificity is very good because it is the ability to distinguish non-epidemic cases. And for most models, we have seen that it was greater than 80%. But in terms of sensitivity, which is the ability to classify epidemic cases, we are not sure because we are still collecting data and we are waiting for those high epidemic years to see how well these models would predict the risk of FHB.
That's right. Confidence is just lower on that side of the models. And so we need to build that up for sure. Yeah.
And I can just quickly add that that's not to say that we did not see any.
No, that's right. We did see some
today. So we actually saw, just that it wasn't as well expressed as it would have been.
That's right.
in a wet year.
Correct. That's right. Yeah. There were just fewer. Yeah.
You know, in early 2022 was a wet year, right? We couldn't get on the field, but you're talking about having the weather be in a certain way right at the flowering stage, and that might not necessarily have been the case. So when people think about rainfall, it's not just rainfall at any given time or precipitation annually, right?
Yeah.
It has to be a combination of the right timing for the disease to develop. So it's important to recognize that it's not just drought versus wet years. It's also when that happens, right?
Correct.
So,
and we did. I mean, Taurai tested different weather variables. Some that were 4 days prior to plant flowering, 7 days, 10 days, 14. And the best models were all either 10 or 14 days prior to flowering. So you can have wet conditions beginning of the summer, may or may not do anything. But if it creates humidity under the canopy and creates a high humidity level, well, that turned out to be a very common risk factor if it happened in that time period, 10 to 14 days prior to flowering. So you're right. It isn't what happens anytime. That's when the infection actually occurs, is right. The highest risk of infection is right at the flowering stage.
Great. Thanks. I have quite a number of questions coming in, so I'm going to try to get through them as best we can. So Crystal asks, can users zoom into the map to get a closer regional view of the risk level in their area?
Yes, they can. They can zoom in to get a closer look. I mentioned that the resolution, the finest resolution is 10 kilometer by 10 kilometer.
Right. Yeah. So it's not going to show an individual field. Just to make it clear, you're not going to, here's my field and here's what it says. It's not going to do that, but it'll give you a 10 by 10 kilometer grid with some kind of a risk level. Yeah.
Yeah.
And associated with that, there's another question saying, can you address the plan to get this into the farmer's hands?
Oh, we should show Timi's first slide. There's a URL on there.
Right.
That's where you go.
So when this is actually launched, I guess you mentioned April 12th, was it?
Yeah, that's right.
So they will be able to access it just through
that's right.
that URL, I would imagine.
Yeah. If you click that right now, you'll go there and it'll say, here's the Fusarium head blight risk mapping tool. And then there's a little link underneath that says coming April 12th, click here and it'll take you to the map. That's what it says right now. But on April 12th, you click it and you should then get a screen that looks like what it looks like here on Timi's slide.
I guess we got to get the word out to people to know.
We got to get the word out. Absolutely. And that's partly what we're trying to do today and we'll be doing. We'll be sending out a press release ahead of that rollout on April 12th as well to try to publicize and get this out across the provinces so people know about it. Yeah.
Great. So moving on to the next question, if that's okay. Of the sites that you used to collect data, did you have irrigated or were they all dry land? So were the irrigated fields? Go ahead.
Taurai knows this, I think, yeah. Because I think there were some irrigated fields. Am I mixing up my projects here? Were there some of the fields that were irrigated?
Okay, so for plot sites,
plot sites, not fields. That's right. Yeah.
So these were all dry lands, but for some of the Presa-field data set, we had some of the Presa-fields irrigated, especially in Alberta.
Oh, okay.
So for those samples, there was a different validation that was done. Because the idea is that when you are developing these models, we don't want irrigation because we are depending on the rainfall precipitation only, because this is the data that we are going to be using to predict these models. So we are not going to be getting irrigation data from farmers. So we remove that irrigation data from our models because it will be variable from farmer to farmer. So the model development, which is the plot size data set, was only based on the dry land data set.
Yeah, the actual website has a disclaimer and it says, if you're irrigating, the risk levels that are being shown are based on rainfall, and your risk level in an irrigated field is likely higher because you're adding more water. Yeah.
Makes sense. Okay, moving on to the next one here. How different is the FHB versus DON risk? How would a farmer decide which parameter to use as a basis for their spraying decision?
That is a good question. There is a choice there, and the truth of the matter is that sometimes those, like FHB that you measure in the field, may not be highly correlated to the FDK you see later or the DON, and so that there is a choice. And I mean, I think choice is a good thing, but this is the downside. Now, the good news is you have a choice. The bad news is you have to make a decision. So that will vary, I think, with each producer in terms of what's most important for the end use of what they're planning to do with that cereal.
And I should also maybe quickly add that oftentimes with the FHB expression, oftentimes it doesn't really necessarily mean a reduction in yield in terms of quantity of yield. It may reduce yield slightly, let's say spring wheat from 60 bushels to the acre to maybe 57, 58. So it's not a drastic yield quantity in terms of the quantity, but oftentimes it's mostly about the downgrading. And that's where the economic loss factors in. So I think there was a study out of Alberta that shows up to $100 per acre loss if there's a downgrade from grade 1 to feed. So basically, again, oftentimes the producer would have to decide, am I really interested in looking at DON as the DON risk, or is it mostly based on the Fusarium damage canal?
Yeah, no, that makes sense. Okay, the next question is a fairly broad one, but if I could ask you to tackle it, what do you predict about climate conditions in Canadian prairies in the next 25 years? And what source did you use for this prediction?
Well, I know that like anything that I've seen talks about, rainfall levels perhaps increasing slightly, as well as a warming of temperature. And that's an interesting combination because while you may be getting more rain, you're also getting higher evaporative demand. And really for cropping in Western Canada, the question is, how is that balance? Are we going to see enough rain to make up for the additional evaporative demand that comes with warmer temperature? And that I'm less certain about what the actual stats are saying. But those are two very key questions. The sources, you can go to the Prairie Climate Center at the University of Winnipeg has things. I believe you can also go to Environment and Climate Change Canada to look at some of the forecasts that are coming out there as well. So there are various sources for those sorts of predictions, yes.
Yeah, and warmer and weather, if it's warmer and wetter, meaning more water, that's probably not great news for FHB. But
no, it's not. Actually, the risk is likely to go up. Yep.
Yeah, but one thing I think that we also maybe need to be mindful of is about the timing. And that's something we've seen lately with the, I would say, rainfall pattern we've seen, especially in Manitoba, in terms of sometimes at the end of the growing season, the total may not be so different from the climate normal, which is the average over the last 30 years. However, the timing has been quite variable, such that like in Brandon, I think 2018, 2019, they had about 6-7 inches of rain in a day. Now, when we look at the end of the season, it's showing, yes, the end of the season, we have the normal precipitation, but the timing, and one of the things we've seen, at least again in the last few years, has been the timing, apart from the total, but the timing during the critical growth phase and the flowering has actually been slightly drier than what we've seen historically.
okay. I have a few more questions here. We'll try to get through as many as we can. Is there any way to adjust for other possible site-specific risk factors, such as disease stubble, for example? Mary asks.
Yeah, not in this model. We don't have that built in as a factor. There are countries in the world that do take that into account. Disease stubble, did you plow it, or how was it managed? Those things are out there, but this was not one of the factors that we included in this model, so it does not take that into account.
Great. A viewer asks, it is mentioned the lack of data and the need for higher disease pressure years for more accurate model validation, which we covered so far. Question is it premature then to launch this model?
Taurai, talk about, Taurai tested the US models
Mhm.
that are in use right now in Western Canada against the ones that he developed. Tell them about your results there, Taurai.
Okay, so for the models that we developed, we noticed that the models that we developed with higher accuracy. For example, one of the spring wheat model had 75% accuracy, and some of the winter wheat models is greater than 80% accuracy. But however, if we take the US FHP model that is being currently used here in the prairie, it had about 59% accuracy.
Okay.
So that tells you that there is still
Yeah.
greater improvement with the
Yeah.
models that we developed.
Yeah. So we think they're ready to launch. You know, yes, they can be improved, but we think they're better than what we have right now. Yeah.
Yeah, and I would also want to think that with the changes in chemotype, it does also really maybe shows that the new data set that we've collected, despite the dry bias that it may have, is still better than what we've been using historically over almost 20 years without any change to it.
Yeah, so any improvement is good news, right? So obviously
Absolutely.
it gets refined over time, but
Yeah.
we're confident that it's ready to go. I think it's good to have that tool available to our producers.
Yeah.
Okay, I'm going to move on to the next one. To what extent of data did you gather for each variety to accurately show what level of resistance it has to plug into the model? Is it company data? Is it breeder data?
Well, this is the data that would show up in something like Seed Manitoba or Saskatchewan or Alberta. So they would go through and they will list all of the varieties, and they'll list the ratings that they have for midge tolerance and all this kind of thing, including FHB resistance. And my understanding is that comes from the FHB test sites that all of these varieties have to go through before they're registered. So that's what we use. Whatever is published in those seed tables, which comes from the research that's done on them, that's what we used in ours. Yeah.
Okay, great. We have a couple minutes left, so I'll try to get through a couple more here if we can. Don Norman asks, are there any other weather-related diseases that this model and the higher res weather station networks could be used for? So beyond FHB.
Go for it, Timi.
Yeah, we've actually had some conversations around sclerotinia for canola, possibility for potato late blight as well. Like any disease that is impacted by weather, which we have quite a ton of those. Now the challenge is that we need to do what we've done with this project, which is have a test site to develop the model and then validate the model on producer field. So it won't happen overnight. The good thing though is that we have the data already being collected in terms of the weather data. So I think that aspect we already have, but then we also still need to have the boots on the ground, have the seed in the ground, and do rigorous model development and validation.
Yeah.
Yeah, no, that's great, and it's a great place to close our session today too, because I think you demonstrated it works for FHB, and it's going to make an impact, hopefully, for our producers, a positive impact, and hopefully this will become a model. The model itself become a model for other diseases and other varieties going forward. So
that would be wonderful. Yeah.
Yeah, I do think we're out of time because I wanted to make sure that I do thank you all for joining me today, particularly our presenters, Paul, Timi, and Taurai, for sharing their knowledge and discussing this issue with us. And for all the questions we received from our audience, I really enjoyed the discussion.
Yeah.
And your time and the audience's time is really very much appreciated. So thank you all.
All right. Thanks, Nazem, and thanks, everyone.
Yeah. No problem. And before we close out, I did want to mention, put a plug in for our next conversation. So the faculty conversation, the next one will take place in April. And our topic at that point will be cover crops. So make sure you watch for event notices on our social media accounts or by visiting makemanitoba.ca. And with that, I thank you all and have a great rest of the evening.